Hello everyone. How was your spring break? Good. Yes, so we passed half of the course. So I would appreciate your involvement in this in-person class and online class. So from now, today we will finalize the intercepting communication module, and then on Wednesday this week, we will start a new module, the cryptography. Okay. So I think I will. I just I didn't cover the level 11. Uh, uh, no, level 12, 13, 14. Maybe that is the last topics for today. So how about we explore the challenge first, and then deep down dive into the some concept and some technical the details. So let's see the level 12. Oh, manually send an ALP packet. Actually, ALP, that is the IP layer, the protocol. So they convert the IP address to the MAC address, right? And MAC address to IP address to communicate in the local network, exactly the subnetwork. So what is the subnetwork? The broadcasting domain. If I send some message, everyone can receive that message, no matter what the IP address or MAC address. So that's the broadcasting network and domains. So in order to communicate with other hosts in the subnetwork, in local network, so you should know the MAC address first. To find that MAC address, we used ALP protocol, right? So in the level 12, we can craft the ALP package what you want and send to the target, and we can get the MAC address of remote host. Why we need to know the MAC address of remote host? Yeah, to communicate. But in this level, so we are trying to false the ALP, the MAC address. So after finding out the MAC address of remote host, so we will uh, update the MAC address table. So we call that ALP cache tables. So that impact on routing the packet. So that's the basic foundation to intercept the communications in the subnetwork. Any questions for this theory? Yes, good. And how about level 13? Hijack traffic from a remote host using ALP. Yes. If you get the informations of MAC address for targeting host A and host B, so we can impersonate, we can the false, the ALP is mine. How can we do that? Anyone knows? How can you uh, false the ALP cache? What kinds of packet you ARC, ARC? Uh, yeah, so we have to send some forced the packet, the ALP packet. We call that the reply response packet. The ALP response packet to the ALP to the target, the remote host. After that, What is neat in level 14? Yes, man in the middle traffic between two remote hosts and inject extra traffics. So eventually, yeah, this is the intercepting the communication. So another name of the attacks, we call that man in the middle attack, MITA, the man in the middle attack. So in these attacks, we have to know the victim's the MAC address first, right? And what we need the further to intercept the traffic. Okay, we can make the craft the ALP packet to fake the network. We can do that using ALP packet. And then what you need to intercept the traffics. So we can craft the packet based on ALP, the MAC address and IP address. What is the top layer of that? TCP layer, right? So in the TCP layer, what is the critical the feature to the maintain the virtual circuit like connections? So we yes, it has 2 weeks, maybe 10 days ago. I explained what is the virtual circuit in TCP. So TCP is connection oriented protocol, right? They made the virtual, the logical line, logical connections between two parties. How can you do that? We use the sequence number, right? So do you remember the postcard instead of letters, right? The long letters that is inefficient to transmit, but let's cut that letters as a small size of postcard, and we can send the postcard and numbering the continuous number with continuous number, and the receiver side the reorder the based on that sequence number. So that is the basic concept of TCP connections. So in the level 14, you have to figure out what is the sequence number between the two parties. So you have to monitor first. Oh, what is the sequence number, and then you can predict the sequence number, the expected number of the sequence. You can make the based on that sequence number to communicate to intercept the communication. Okay, that's the outline for level 12 to 14. Okay, so let's have a review ALP request. Um, so ALP stands for Address Resolution Protocol. So actually, in the subnetwork, in local network, we don't use the IP address first. We use the MAC address first. We don't need to add the IP header to communicate in the subnetwork layers. So we used ALP request ALP protocol together to find out the MAC address. Here there is a three hosts: A, B, C, maybe Alice, Bob, and Charlie. So they are assigned with this IP address 100, the last digit. Here 100, and host B 10, and it has its own MAC address A3 and B8. Okay, let's type ALPA. This number, this command show the contents of ALP cache, right? But empty. There is no any communication between them. So let's make some connections using ping commands. What is the ping? The test the reachability of remote host, right? So ping and the target IP. they show the reachability of that the host, remote host has this IP. So it return with this MAC address. Okay. Oh, this is not return. This is the request. Uh, at first, this request A3, the host A send ALP request who has IP10. If you has if you have this IP, tell the IP address 100. Okay, so this commands typed on host A, right? So we call this who has. This is the operation mode in the in this packet. So ALP packet has two operation mode. The first one who has packet. Second one is at packet. So this is the reply, the response to the source. So host A send the ARP request, the broadcast to the network. So host C also receive that packet, and host B receive the packet. But actually, this IP belongs to host B. So host B responds to the host A, right? So this is the reply is at data operation mode. So in this way, they can communicate after these two request and the response, and then they show the reachability. So in the steps LPA again to check the cache. Yes, it has the IP and MAC address, right? And at the host B also you can check by ALP dash A, right? So we can do this in the real world, in the our dojo. Okay. So I will start at level 14. It has a great environment to show the demo. Oh, it takes a long time. More than usual. Really? Okay, let's refresh. Okay, let's see the my host. Okay, let's see the ALP table. Okay, only one. Okay, and I have config. So my IP is 130 here, right? 130, and MAC address is 1D. So now I just my ALP table, yeah, only connection with the gateway, with IP the 80 the dot one. So I like to ping the public Google name server. So the server is alive. So let's ping phone. So this is not the normal just response time. So let's check again table, the cache table. Only one. So why the no state? I don't know. So this is the real the environment connected with the ASU network. So let's check the app table. Yeah, the bunch of IP and MAC address mapping information there. And check that again. Connections. So sometimes I guess these situations, but I believe the probability is so low to happen this situation. But today I got these situations. Anyway, um, so do you have any questions regarding the ARP protocol? So ARP protocol has two types of packets: who has and is at, right? So they translate the packet at the IP address to MAC address to IP address. So that's the role of ARP packet. And spoofing. What is the spoofing? Pretending. Yes, to make you believe this is a real, this is a true, but that's a lie. Uh, or sometimes we call that the poisoning. Poisoning. So ALP spoofing. Uh, in these attacks, they are trying to make you some specific MAC address that's a mine, or so you can send the packet to me in the subnetwork. So that is the basic approach, the purpose of the spoofing in AR spoofing. Okay, so this attack the exploit the stateless nature of ARP protocol. So ARP the cache table can be saved in the local server or in some specific switch device, switch equipment. But in this small local network, most of the OS, most of the hosts, they maintain their own ARP cache tables, as I shown. So that means, yes, the ARP cache table, there's no any controller in the subnetwork. So we can control that ARP cache. How can you do that? So that is the ARP spoofing attack. So attacker host send spoofed ARP message to two victim host, the poisoning their cache. So the victim host send the API packet based on their the mapping table, the stored on their local the place. So the attacker host act as a router. Actually, the router has the all mapping table between IP and MAC address. So the host, they use two types of address, right? The first layer, first address MAC address, and second address the IP address. So I'm gonna show the demo ARP spoofing here. Yeah, again, there are host A with this IP address, the 183, and host B, they have relations to communicate with the number, the IP 10, and MAC is a B8. So Charlie, who's the C, his IP 138, 137, and MAC is AD. So how can the Charlie send the fake false a packet to host A and host B. So to host A, hey, I'm host B, and to host B, hey, I am a host A. So that's the basic theory for the host C to make the believe, right? I am your partner. So as I said, there's two types of ARP packets, right? So this is the ARP, the framework ARP packet. The host C send the packet made like this. Okay. Um, the ARP packet type, the second is a reply, the is at, right? Operation mode is at. So to the 100 host, the host A send this packet. Hey, the IP 10 is at the MAC address A0. So I just named the last digit and last hex digit. Okay. So this is the uh, make update the ARP cache of host A. So that's the nature of the ARP protocol. So very easy, right? So you can just send this the crafted packet to the host A. In the same way, you can send to host B. Hey, host the 100 is at with this ARP MAC address AD. So actually, this AD is Charlie, right? And also the first packet, the AD, also Charlie. So make them believe that IP belongs to me, uh, right? To host A and host B. So this is the outlines of the ARP spoofing. So after that, they will to send the packet. They will intend to send the packet to host B from host A, but that will be delivered to the host B. Why? The ARP cache updated, right? That IP belongs to this MAC address. The MAC address that belongs to host C. So host C can intercept the data. Here, let's say the secret data. Host C can read that data, and host C check. Yeah. Okay. Okay. Thank you. So host C, and then the replace the data with his secret. Okay. And then the host B the believe this secret was sent from host A. So in this way, you can uh, the pretend as I'm a legitimate partner of you. See? So how can you do that? Okay. So LP spoofing use the LP replies, the is at packet. Okay. So it might restore the LP cache to the correct value. So most LP spoofing tools repeatedly send because each packet has some time threshold. We call that time to light (TTL) information. Only that time frame it will be valid. So after that time, the LP cache should be updated. So the attacker should repeatedly send the fake response packet to the target devices. So the error cap that is one the tools for this role. How can we defend this ALP spoofing attack? The first one is ALP inspections. So like a dynamic ALP inspections. So only ALP packet, the response relayed. In this case, you have the original, the genuine, the mapping table. A and A is 1, B is 2, like this. So you have original copy of the ALP. If you have the original copy, so you can inspect the packet. Uh, do they violating or not, like that. That is dynamic API inspections. Second one, the network segmentations, the dividing the network into more the smaller scales, so that can remit the breach of LP spoofing attack. Third one, so we can use some security product like IDS or some network manager tools. They can detect the unusual ARP traffic. So they have the informations, what is the original IP and MAC address. So based on that, also there is kinds of inspections. Um, so IDS can detect and also they alert to the admin or some corresponding first person intrusion detection systems, and VPN. So ASU also use VPN, right? So what is the major role of VPN? They are encrypting all traffics, right? So you cannot see the contents of the packet. So last time I also mentioned about the SSL or TLS. So there can be solutions to prevent from spoofing attacks. Okay. Okay, let's back to the dojo. Okay, let me show the some. Still not. The SSL is not working. Not working? The website is up. So this is not good time. Let's use desktops. Please. Okay. So here, one. So let's see. Go to the root reviews. Okay. So let's see Scapy. IP. No, right? So let's ping 10.0.0.3. After these connections, let's check again LP. Yes, it has cache 10.3.3. I need to one more ping 10.0.0.4. Okay, so let's check the table again. Yes, it has two IPs and MAC address. And we can see, let's try to, how can we send the LP packet in the level 12. So we used, we are using now Scapy, right? Scapy. Okay, let's figure out. We can s- again let's check ALP cache tables and um, yeah, as you see, some list is that disappeared, right? 10003 removed from the list, right? Yes, now the lists are all cleared. Okay, let's check with the Wireshark what changed. Let's run our Wireshark in the background. Oh, okay, and run the capture ETH00 and let's ping 10.0.0.3. Yes, so the first packet who has, that's a recast packet, right? You can see the details of the uh, packets. It's an ALP packet. So you can see the OP code is a 001. Okay. How about the response here? Yeah, 002. 02. That's gonna be the is at mode, the response packet. So we need to create the craft. We need to create it, this two packet, uh, the second packet, the response packet, to update the cache table to remote, right? And so let's make the TCP three-way handshake and see. Let's just okay. Yes, all cleared again. The cache table is cleared. Okay, and let's see NC 10.0.0.3 and phone number, the random number like this. Okay, so it has some data secret. So the first one is an ARP packet, right? Who has this IP? The IP is at this MAC address, goes to ARP packet, and then three-way handshake with the sync packet, right? Sequence number 0, the relative number, and second sync ACK, and third again ACK, and then the data transmissions with the push flag, right? So in this case, the length 8. So what's the contents of data here? Yes, it has this the character secret, right? So after this send transmit, and then the ACK gonna be the accumulate with the size of this length, right? In the ACK number. So here you can see the 9, okay, and then the length again the 0, and here the length 29, right? So the 29 uh, so will be added, accumulated with the, the acknowledged number, like this 8. Okay. So the during, so we can check this mechanism. So the first ALP request and response, and then three-way handshake. After that, the data transmission. So you need to understand this, the establish the setup process to analyze the connections, predict the, some sequence numbers or numbers. Okay. So ALP and yeah, there's no. So let's make 1003. So it has ALP cache. So in this case, in this situation, at this moment, try to 003 and put make the three-way handshake. Okay, so good. So let's go to the Scapy to make the ALP package with the Scapy. Okay. How can we see the structure of the ALP package? Uh, LS, ALP. So they are case sensitive, so you should use the capital. Yes. So the first field hardware types, IP types, and hardware length, and OP. Yeah, this OP mode is at or the who has, right? And hardware address of source and the source IP field, okay, and hardware address of destinations, so IP address of destinations. Okay, we can so ALP, the basic structure. We can check ALP this way, show method. So the color is not invisible almost. Um, so how can we make the Ethernet packet? So we need to import from so import first and uh, okay my MAC address. How can we get this MAC address? Do you remember the function? Interface, right? Let's see. Get oh get interface um, Mac, right? ETH interface name. And let's check. Hard Mac. Get it. Okay, and second, let's define the broadcast MAC address. Usually FF 3, 4, 5, 6. right? Now we can make the packet. What is the name? Either. Sorry. Okay. And source is source. Address my Mac, right? And destination. So broadcast Mac, app, right? On top of this, so we now make the ARP packet. So OP mode. So to update the caching table, what we need, what kinds of ARP packet, the operation mode. Who has? No, is at, right? So you need to use is at. That is the response packet. And a hardware source. So my Mac and IP source gonna be. So let's spoof the 10.0.0.4 or 3 first. Okay. Oop. Okay, let's send this packet to the 10.0.0.3. So what's the function for sending? Send p, right? The packet and interface e the 0. Okay, okay, send. Okay, send. So in the Wireshark, the black line, that kinds of packet has this packet has some errors. So you need to ignore the black packet. Anyway, I sent that one packet, and also we can send that packet to full. Okay. Send packet. Yes. So in this way, check LP. So TCP dump. TCP dump. Interface. 2. Yeah, it can now the 10.0.0.2 the listen the traffic from 10.0.0.3 and 10.0.0.4 because it has the 10.0.2 has the MAC address of both parties, right? Um, okay. Because I didn't run the TCP dump first. This is the another the shell virtual network space. So when you type, yeah, it doesn't have any cache tables. And let's see the TCP dump interface. It the true. So this is the status of people the spoofing. So it cannot monitor any traffic between the 3 and 4 of IP address, right? But after spoofing this virtual network, so I can hear the traffics, right? So you can see this some human readable types like this, the A options, dash A options, or you can also using the X options. Okay, but in this way we can send the LP cache. Yeah, we can update what you want uh, for the cache tables, and we can intercept. Actually, we can listen. We can monitor the network traffics. Any questions? Okay. So IP6, this packet is usually the meaningless. You can ignore. And then, um, so now we can send the ALP, the forced ALP packet to the target, the victims. See again. Now, in the level 14, we have to predict the sequence number. So in the real world, that is not easy, very hard to predict the sequence number because already a lot of the defense mechanism like ISAN randomizations or a lot of encryption protocols are deployed. So in the real world, it's not easy, but let's have a review how to predict the sequence number and acknowledge number in the level 14. So you can do that and get a flag. So what is the sequence number and ACK number? Here, let's say we the sequence number specify the positions of the data in the packets. Okay, so let's say the sequence number 113,423 means the payload of this segment contain the if the payload 35 the contain the data from the yeah this the number to the 58 the at this size, right? It means so the sender sent this number as acknowledged number specify that specify the position of next byte expected from the partner. Examples, act number 16754 means I have received primary data in the stream, so I expect the next byte gonna be the plus one for this act number. These numbers used to manage retransmissions or the duplications and flow controls. Okay, they can be used for the maintaining for these features. Okay, this is the TCP three-way handshake again. The sync packet. This sync is a flags. This packet will set the sync flag and sequence number A, the receive, the host B, the reply with the A plus one for acknowledged number and sequence another the random number the B can send to the host A act reversely the conversely the sequence number the acknowledge number will be increased by one, right? And the sequence number the same with the egg number of the host B. So this is the three-way handshaking. In second phase, data transmissions. The push and egg flag are set, and the number, let's say hello world. So this sentence has size of 13, right? So the egg number will be a plus 14. The 13 will be added to the sequence number, and the sequence number is the same as the egg number. Those to be sent this packet. When the transmissions are finished, the host A send the fin and egg flag set packet. If the host B responds with the plus one for the sequence number as an egg number, and finalize with this the same mechanism. Okay, so this is the rules to number the sequence number. Okay, and let's back to Dojo. Okay, so we successfully update the cache table with our host informations, right? So now the host, the 002 has these two ARP cache tables. So we can now trying to intercept the traffics, add some the data between the traffics to get the flags. Uh, how can we do that? Yeah, we have to know what the sequence number and acknowledge number based on the rules I described, right? So you need to monitor the sequence number and ACK number, how they exchange that number. First, the packet. Uh, in order to that, we have to use some capturing packet, right? Capturing tools like a TCP dump or a Wireshark. So we use that tools, and also we can use the Scapy. What's the function for monitor or capture packets in the Scapy? Sniff, right? Sniff. Using the sniff, we can uh, capture, and also if we use some Python functions, callback functions, we can filter the specific conditions based on uh, some the patterns or some conditions. Uh, we can make uh, some the branch to the other operations or other work like that. So see here, I'm trying to the capture using TCP dump first. Okay. TCP dump interface either 0, and uh, we can use some options to save the packet, capture the packet. So do you remember what's the options? So let me see. man TCP dump and slash w. Yes, so slash w uh, possibly push. Yeah, to save the low packet output packet buffer. So we can use the W options. TCP dump interface is 0, and so we can use also some hexa view for analyzing, and so we can save the file name how to say ASU and pcat. Okay, let's give some maybe 30 second 30 second for capturing, and then we can import these files to where, okay, Wireshark, right? So we have captured 204 packet, and we could use the Wireshark files, import, open, ASU, pcat file. Yeah, we have a lot of packet. Okay. It is not easy to see the functions. So it has some data with a character secret. So here it has some like hexa streams, maybe hash value or and commands ds echo plex. So and command and echo. So you just need to see the push and echo packet, because that's that indicate this packet is a transmission of data. The push and echo. Okay. And hello world here. Yeah. Again, this is the three-way handshake. Okay. So again, repeatedly they showed some specific character, like commands echo, the flags commands, hello world, and some hexa streams. So I don't know what is that. So anyway, we have to guess that to see using just X options. Oh, so we can see more obviously the data of each packet, right? Okay, let's see. you can see also that repeatedly they showed the same character or the commands. So now you can see the sequence number here and X number, and you can predict what's the next sequence number between these repeatedly to transmitting the data. So you can inject your commands between some point of these repeated packet transmissions, and then you can get flag steps. Uh, but how can we do that automatically captured and predict the numbers and inject some commands? So we use some the functions of Scapy, the sniff, and also Python callback functions. So I brought some examples. Okay, so this code, the sniff of Python. So you can define some callback functions to monitor some specific conditions. Okay. So here, these functions, the sniff need the callback functions. The name's packet callback here. So the packet has some raw data. You should print out that from the interface either zero. So let's learn. Oh, sorry, Python sniff. Yeah, it didn't have any capture the packet now, but let's see. We can repeat it. Okay. We do this. Let's move intercepting and lecture. Let's move. Okay. So I will learn that code. So this code extract the payload data like this. So if this 10002 received some data from 10002, 10003, and 10004, right? And against that, the packets, let's extract only the payload to predict some inject commands. And if you uh, if you can guess, so what commands or what data needed for intercepting these traffics. Also, at the same time, you have some skills to predict the sequence number and acknowledge number. to, to make the intercepting a packet. So you can use this script and for level 10, level 14. So you can see that they show the repeated the streams, right? But I don't know how can solve these challenges. Okay, any questions? Okay, good luck for your last challenges, and let's see continue the cryptography on Wednesday. Have a great one. Bye.